the chips were getting so hot that they even started to melt themselves. They were so powerful. They were consuming so much electricity, and that's very proportional to the heat that they generate. And so, people who were using those higher end chips and calculations 20 years ago started to investigate the use of liquids for reasons like George mentioned, dielectric breakdown, and others. And then so recently, as we've hit the AI boom, they have to have that. There's really no option to even use air cooling anymore. The chips require so much power that they don't have a choice but to use liquid cooling.
What does a Kentucky-based company that makes oil for your car have to do with cutting-edge data centers that power artificial intelligence? The answer lies here in Lexington, Kentucky, with a company I'm sure you're familiar with, Valvoline. We got to sit down with Valvoline's VP of Research and Development, George Zhang, and their Director of New Ventures, Michael Morrison, to get up to speed on where Valvoline is headed into the future and how AI fits into that vision. Before we get into this episode of Middle Tech, we want to take a second to highlight the partners that support the work we do in highlighting technology and innovation in Kentucky.
Before we highlight our sponsors, we'd just like to state that the views and content shared on this platform do not necessarily reflect those of our show sponsors. That being said, Middle Tech is supported by KY Innovation, the Kentucky Cabinet for Economic Development's Office of Entrepreneurship. KY Innovation exists to support and develop Kentucky's startup ecosystem, and we are proud to be supported by an organization whose mission aligns so closely with ours. If you are a founder building in Kentucky, you need to check out the resources that KY Innovation has to offer. You can find more information by clicking the link in our show notes or going to kyinnovation.com.
Valvoline's origin dates all the way back to 1866, when Dr. John Ellis first discovered the lubricating properties of crude oil and developed the first petroleum-based lubricant. The company gained prominence when it became the recommended oil for the Ford Model T, one of the first mass-produced automobiles to hit the market. Each Ford Model T came off the factory floor filled with Valvoline's oil. Valvoline's story intersects with Kentucky in 1949, when Ashland Oil, which was a large oil company based in Ashland, Kentucky, my hometown, acquired them. While their headquarters has operated out of Lexington since the 1980s, their current headquarters was constructed and dedicated in 2017. The same year they spun out of Ashland Inc. to become an independent company, and just a year after going public on the New York Stock Exchange at a market cap of $4.8 billion. Most recently, Valvoline's lubricant unit was acquired for $2.65 billion by Saudi Aramco, the world's largest oil company with a market cap of $1.5 trillion. Their headquarters remains in Lexington, Kentucky. In response, they've taken a large step into coolants, producing products for electric vehicles and most recently, data centers.
You transitioned from an oil company to a chemical company. I'm very curious, when I toured y'all's facilities, it definitely felt like a chemical company. The experiments you were running, the different ways you were applying the chemicals. Why is it conducive of an oil company to change into a chemical company? What is it about petroleum that has so many applications to all these industries you mentioned? What is it that maybe you can give us some background on about oil that makes it so applicable?
Should we take it? Yeah, sure. So talk about, let's say, from the oil perspective to the chemical perspective for the Ashland transition is really looking at the value of the product you can bring to the marketplace, right? So the petroleum side, you can make fuel, you can make, let's say, the lubricant-based oil. Then the chemical side, you can make a lot more, and you can actually bring a lot more value to the product. Just, let's say, turning the company focus from petroleum alone to the chemical. That's actually what we are now acquired by Saudi Aramco. Actually, that's also Saudi Aramco is also looking into how can we really add value to the product. Eventually, we want to, let's say, the petroleum will be turning to energy, and how do we make the energy more efficient? That is really one of the things we are looking at, right? So not only making the let's say the basic product, making more advanced product, also making the product more efficiently.
And I'm curious with the R&D side of this, I mean, just kind of give us a sense of where the space is headed with the current state of it. I mean, how much more innovation can we draw from something that's been around as long as petroleum? How close are we to the cutting edge? Like, just kind of walk us through your perspective on that as somebody that's in the R&D space.
Thank you, Logan. That's a great question. So, yeah, people think we are a low-tech company because petroleum has been around for 200 some years, right? The research, the R&D, the technology. So again, there are still a lot more to be done. So from let's say what we are doing, the lubricant R&D perspective, we are doing a couple of things more like the cutting edge, still leading into the future. Number one is really efficiency. I mentioned efficiency earlier, right? Fuel efficiency. How do we make the equipment to be more efficient? Not just the engine, but also a lot of the industrial equipment, heavy machinery efficiency. Lubricant can help dramatic with efficiency. Number two is durability. So how can we make the cars, the machines, everything to last longer? Again, the lubricant product can help let's say, prolong the life for the equipment. And number three, the emission control. And from our perspective, how do we research? How do we come up with formulation to help the engines, the vehicles to produce less emission, including the emission coming from using our products? So quite a lot more to learn from that. And we actually touched base on Formula One earlier, right? So look at the Formula One car. So how do you extract the power from the engine to make it to go, like say, 0.01 second faster? That's actually quite a bit of science and the technology behind formulating the lubricant to enable the engine to be more efficient.
So with all that R&D, I'm sure comes, a various and large product suite. So give us an idea of kind of the stack rank order of, your products and the percentage of maybe revenue. You don't have to give, details, but give us an idea of what your portfolio of products looks like.
I mean, it's no secret our core business is automotive lubricants, right? It's been our core business since the automobile first came to life. We were a part of that first automobile, so we know a lot of history around that. That's what the consumer understands about Valvoline by nature, is that this is a heritage brand that's been doing automotive lubricants longer than anyone. And so that's still going to be the largest piece of our business as we go into the near term, right? As the world evolves, things are definitely changing with our portfolio. But what is kind of interesting about it is that it's the application that's changing. It's not necessarily the core chemistry that's changing behind it. So if you think about oils or coolants, there's a lot of other applications out there that are starting to generate more and more heat in the world. And so oils and coolants have a unique ability to help do that maybe air doesn't. And so those are sort of the next steps with the innovation in our portfolio of where we're headed.
Yeah, super cool. But back to kind of the theme that you were just talking about there, the evolution of the company and getting into different applications for your all's products. Walk us through how you guys got into this data center coolant business. I mean, how was that evaluated and why did that seem like a good, sort of revenue channel for you guys to add to your suite of products?
So a few years ago, preceding our Remco acquisition, that became a really important thing for us. Where can we apply our expertise? We have some of the greatest chemists, some of the greatest engineers in the world. And so where do we take our company in the future beyond just automotive lubricants that you guys mentioned before? And so folks like George have this tremendous expertise in what can oil actually do. There's many properties of oil besides just lubrication. And so we looked at applications that were producing challenges or had knowledge gaps in some of the properties of oil. Cooling is one of those. And so we relied on our heat transfer experts, again, like George sitting next to us, and said, can we help this industry? And it seemed like we could. I mean, you can speak to some of the early approaches we took with that.
Sure. So yeah, thank you. So we look at again so Logan, the question is that we were looking at how can we future-proof the business. We know electrification. We know a lot of the future trends are really making, let's say, lubricant market relatively stagnant or maybe going down in the future, maybe, right? So we don't know. We don't have a crystal ball to tell the actual fact. Well, the trend is there, so we have to future-proof the business. So Michael and I, actually, we were in a team to look into how we can take our expertise going to a different marketplace. So again, Michael mentioned lubricant itself has four major functions. Number one is lubrication. Number two is clean. Number three is seal. Number four is cool. Actually, people don't know actually cooling is a critical factor for the lubricant to function in an engine. So we look at that aspect, then we look at heat transfer. Then we think, how can we take, oil in our formulation to be applied in other type of cooling demand? Then we actually come across in the high performance computing. And that's the environment that's generating a lot of heat. And people do not have a better way other than air today to cool those equipment. And a typical fluid is about 1,200 times better in heat conduction. So that's the reason we go on that route. Take the formulation to make a dielectric fluid to cool the computer equipment.
And just a question for those who might not be super technical and understand how coolant would work with computers. Typically you think, oh, I don't want to get any sort of liquid at all on any component of a computer. So are these coolants that the computer components are actually immersed in and submerged in? You mentioned dielectric there. I assume that has something to do with not shorting out the circuits on the computer. Can you just kind of explain it like we're five? How does that work?
Sure. Yeah. Thank you. So we actually have two ways. So there's one way is called the immersion, right? So you actually are putting everything in the liquid. So you literally put the motherboard, all the components into a liquid. That's immersion cooling. So that is what we call dielectric fluid. This is a fluid that is actually look like a water white. It's a liquid, but it doesn't conduct electricity. So think about it. We think air is a good insulator. So the breakdown voltage of air is about 3 kilovolt. So that's air. But you look at the fluid we're using, the breakdown voltage is actually 30 kilovolt, roughly around that range. So the fluid we're using is much better insulator. So you're not going to short system at all. So, but we do have another way of cooling the computer system too. Is we call it direct to chip. So you have relatively complicated the design of the flow path of the fluid going through the system and going out. So in that application, the fluid is not touching the components. So we're using water glycol system for that particular application.
Can you get into the problem that the data center industry was run into as they began to try to scale and use more high performant computers and GPUs and things that required and a lot more electricity and put off a lot more heat? So prior to liquid coolant, what were they doing, and then how now that liquid coolant is part of the equation, what's changed?
Yeah. Liquid cooling has actually been around for a long time. It just hasn't been used very widely, right? It's on special applications, large like supercomputing type centers. The crypto mining industry bought into it fairly early. And one of the reasons is, as you mentioned, like these GPUs, these what we would typically call like a graphic processing unit. When I was a child, these things were for playing games, and we plugged them into our computers, right? It was just a great way to be able to go play the latest game that hit the market. And somewhere along the way, people like NVIDIA struck gold and realized we can apply the logic behind that toward things outside of gaming. Like we can find oil and gas drilling sites with them through special processing, or we can create blockchains with these things. And so they discovered sort of a new purpose for their product. And that was sort of kind of what we were trying to do as well. And we came across this and realized as they were doing more and more calculations, the chips were getting so hot that they even started to melt themselves. They were so powerful. They were consuming so much electricity, and that's very proportional to the heat that they generate. And so, people who were using those higher end chips and calculations 20 years ago started to investigate the use of liquids for reasons like George mentioned, dielectric breakdown and others. And then so recently, as we've hit the AI boom, they have to have that. There's really no option to even use air cooling anymore. The chips require so much power that they don't have a choice but to use liquid cooling. And so you're seeing a lot of companies pop up that are making different methodologies to do liquid cooling. George mentioned a few, but there's even different approaches within that. You can have rack-based, you can be in a tank, there's direct-to-chip cooling. Sometimes there's hybrid methods that combine the two. And so the industry is really starting to embrace it. And so we're in like the very beginning of a window that may last 5 or 10 years to where a lot of data centers, a lot of crypto farms are transitioning to that.
And they're probably being designed around the fact of how they're going to cool it. So are you working with like the OEMs? Like, are you working with NVIDIA, Intel, and AMD, or are you kind of working with the third-party vendors that are implementing and installing these technologies in the actual data centers?
Yeah, it's a little bit of both. And so obviously can't speak to specific companies that we're partnering with because they're trying to protect where their developments on it. But we are working with some, and design is a key thing. Like, is the regular, 3 feet long by 19 inches wide server really the right footprint for liquid cooling? And so a lot of our third-party partners are trying to solve that with their own like custom chassis, custom racks. And then some of the original equipment manufacturers are trying to solve it as well to prepare for liquid cooling down the road.
When I think of this space as a whole, you think about the expansion of artificial intelligence. It's scaling at an incredible rate, and people are, it's said that it's going to keep scaling until we run into the bottleneck of we don't have enough energy to continue to support these massive data centers, which is why you hear so much conversation around nuclear and like alternative sustainable forms of energy. Talk about where you guys see this space going, because it seems like there's just going to be more and more data center capacity built. And I'm sure that was part of the calculation that you guys made when you said, okay, we want to get into this business. I mean, just give us a little bit of insight into where all of this kind of goes as we try and scale up the capacity that we have with these data centers.
Yeah, that's another great question. So what we see is that we see, like as you mentioned, the data center will be more and more because of the requirement of the data processing, right? The AI, the machine learning, the multiple, let's say, different pathway of moving to the future. So there will be more and more data center, more and more energy requirement. So I think the energy will be coming from different sources for sure, right? Not just today's generation by petroleum, by wind, by solar, could be by nuclear, renewable, all sorts of, let's say, the avenue to going that way. But from our perspective, we want to make the data center to be more efficient, to use the fixed amount of energy to do more work. So there's a term in the data center, they call the PUE, the power utilization efficiency. So today, the typical PUE is around 2. Or 1.5, which means that there are about 50% or 100% of the energy used in calculation actually is used in cooling. So so one is 1.5 means 50%. If you could use that 50% also used for calculation, then you may not need more data center, right? You can actually have the data center be more efficient. So for the liquid cooling, we have a lot of data, a lot of case study to show we can reduce the PUE from 1.5, 1.3 to 1.03. That is the almost the limit, right?
It's crazy. That's super cool. Yeah, because when you think about like, okay, it's going to take us a long time to build new energy capacity. Like, how can we do more with what we already have? Yes. It's efficiency, and I'm curious what your perspective is on, I asked a little bit about where are we in the innovation cycle with petroleum and those products. Where are we with the coolant side of things? Do you think that there's still more progress to be had on that? Are we kind of pushing the boundary of where we are currently? How much further do we have to go?
That's another great question. So we do have, let's say, existing product in deployment today. So we have those products. We have really good performance data to show to our customers, to our prospective customers. But there are still quite a lot more to do. Number one, we can actually look at the molecular level. We can design the molecule to fit that purpose. So from the petroleum side, we are really refining to picking the existing, let's say, from existing collection of molecules, right? We pick the right one. We refine to that particular range. But from molecular design point of view, we can build from ground up. So that's one way of doing that. Secondly, actually, we are looking at from, again, the circularity. How can we go from, let's say, the bio-based? Can we also take, let's say, certain product which is already available and turn that into the cooling fluid? Again, really lower the carbon footprint as much as we can. So there's still quite a more to do going to the future.
So you guys have been going to industry conferences, and I'm sure this is a question that often comes up, but when you look at the general market of who's entering this space, how do you tell people you differentiate? What's your special sauce? I'm sure you can't get into the details, but I'm sure at a conference you're saying things that are unique to your all's abilities. So what are those?
Yeah, that's a great question as well. We really lean into our expertise. And so the fact that we have been doing heat transfer since the beginning of steam engines, right? I mean, that was one of the things that the properties of that original oil that our founder created 150 plus years ago. It's one of the properties it did, and so we inherently have a level of trust with people. Everybody has a car, you know, in most places. It's one of the things, like everybody's familiar with cars, so they know who our brand is, and so we have like a level of trust walking into that, and so that's something we really lean into. We bring our scientists face forward. So all of our partners have great relationships with our R&D team. And so people who can talk about cooling theory together, whether it's on the hardware side or on the fluid side, we bring them face to face, and they really build strong relationships together. And so those relationships are another really unique point for us that we emphasize of how much we really put into the word partnership. We don't like that word to be cliche. We really want it to mean something.
And just as we, kind of wrap things up here, and we've talked a lot about kind of where things are going into the future, just from your all's perspective, from Valvoline's perspective, what does the future look like for you all specifically? Where do you see growth coming from over the next 5 to 10 years?
So from the growth perspective, we do number one is that we have a pretty good product portfolio, but we worldwide we still have a lot of markets we have not penetrated as much as the U.S. or Australia or India. We have good the percentage of the market share. So those we can still expand, right? So that's the organic from internally, how do we take the product, how do we do the marketing program, how do we reach the customers. Then also look at the new things, the new ventures. How can we take the existing product, the existing technology, and find new uses? So the computer cooling, high performance computer cooling is another way. And lastly, also we're looking at the possibly inorganic growth too. So we're looking at where any technology at a company could be, let's say, complementary to what we're doing. So we could be adding to our bag of tools.
We always love to bring it back to Kentucky. What does Kentucky and Lexington and this region mean to you all? I mean, you guys have offices here, headquartered here. You guys have talent coming from the universities. Give us just kind of a broad perspective on, you're from Kentucky, you've come to Kentucky and been here for a long time and consider it home now. So tell us about why this place is special to Valvoline.
Yeah, I'll start, and then George is a UK grad, so I'll pass it off to him as well. But I think Kentucky is what gives our company a big chunk of its personality. Like I mentioned, our relationships with partners. Kentucky is a very friendly place. Like people are just, they genuinely want to support each other. Kentucky is almost like a family of its own. You run into Kentuckians around the country or around the world, and it's almost like, oh yeah, like we're the same in a way, and there's a bond there. And so I think that is represented in our company as well. We treat all of our clients and our partners and our technology collaborators with that same kind of Kentucky personality when we go to business every day.
I think I'll probably answer the question in 3 ways: talent, resource, opportunities. So from talent perspective, as Michael mentioned, I'm actually a UK graduate. So I graduated from business school in 2007. So I let's say learn so much from going to university, understanding what they're doing, right? So today we have multiple programs running with different professors studying not only the lubrication side, but also even the cooling side. So I can give you guys example. We do work with a group here studying how can we use the coolant we developed to cool the inverters, the converters in electric vehicles. So that's another new area potentially going to the future, right? So they have a lot of talented students, talented faculty member. From resource point of view, we actually are located in a very good area. So we actually have a lot of, let's say, the other resources around us. For example, we were talking about Kentucky actually has a lot of companies coming to do the crypto mining because of the power resource, right? So how can we help to make that more efficient? So last about opportunity, we actually applied for quite a different, let's say, the grant of DOE with universities, and we do see there's the opportunity linking with university in Kentucky, actually in Ohio, Tennessee. We do have a corridor here, automotive and future mobility. So those we see that's a home for us. We can really blaze a new path through working with people, with companies here in Kentucky.
Well, it's been so interesting talking to you guys, and really appreciate you guys making the time. Definitely a company that you drive by all the time, the Valvoline that you might get your oil changed at. It's fun to dive in and hear where things are going and how you guys are thinking about the future. So, George, Michael, thank you guys so much for taking the time to sit down with us and share a little bit about what you guys are into.
Thank you. We really appreciate sharing our story and appreciate you guys having us on the show.